In this introduction to algebra, we are reviewing some of the language of algebra, so some of the terminology that you're going to need. We're going to look at what pieces make up a polynomial and how to simplify a polynomial by collecting like terms. So a variable is just a letter that represents an unknown value or quantity. So letters like X, Y, A, B, S, etc. A coefficient is a number that's directly in front of the variable. So if I have 3x, 3 is the coefficient, negative 2y, negative 2 is the coefficient. If I have just an x, there is a 1 in front. We just don't write it, and it's the coefficient. And the coefficient actually tells us how many x's there are, how many y's there are. An exponent is a value to which a number or variable has been raised. So x squared, y cubed are both called powers, and the 2 and the 3 are called the exponents. The term is just a number or variable or combination of a number and variable multiplied together. So an x would be a term, a 3y would be a term, a 2xy would be a term, a squared would be a term, etc. A constant is just a term as well, but it's just a number. So a constant term is a number like 5 or negative 100 or negative 5. An expression is different than an equation. An expression, we're not looking to find the unknown value of a variable. We're just simplifying and bringing like terms together. So it doesn't have an equal sign. It's like a statement with a bunch of terms added together or subtracted. So that takes us to the definition of a polynomial. It's an algebraic expression with one or more terms, and they're put together with addition or subtraction. So if I have x squared plus x squared plus 2x plus 1, we call this a polynomial. It's an expression where you've got 3 terms added together. One of these could be a subtraction. And because there's 3 terms, we call this a trinomial. Like terms refers to terms that have the exact same variable parts. So if I have 2x squared and 3x squared, those would be like terms because they both include an x squared, the same base and the same exponent in the power. 3x would not be a like term because it doesn't have a squared. Okay, so let's look at some pictures to see if we can look at how we are going to simplify expressions. So here, hopefully you can tell me 1 watermelon plus 1 watermelon is going to give me 2 watermelons. If I let each piece of watermelon be represented with a W, then the expression for the left-hand side would be 1 watermelon. Remember, I can put a 1 here, but I don't have to. 1 watermelon plus 1 watermelon. And I can make it into an equation by putting an equals 2 watermelons. So remember the numbers in front, the coefficients are how many there are. The next picture, I've got a bunch of cherries and 3 bunches of bananas. So I'm going to let C represent an individual cherry and B represent an individual banana. So be careful this time when we're trying to set up the expression. We're going to have 2 cherries because we're talking about individual cherries. Plus we've got 3 bunches of bananas. So we're going to have 3 bananas and another 3 bananas and another 3 bananas. And that adds to a total of 9 bananas if you put them together. The bananas are like terms. And you'll notice that the B's, we're using the same letter, so that's why we're allowed to collect them together. The cherries we cannot add because they're a different fruit. So my final expression is just 2 C's plus 9 bananas. So I've got 2 cherries when I'm done. And I've got 9 bananas. Okay, so now we have 2 cherries, 2 bunches of cherries. So I'm going to represent that with 4C because you've got 2 in each bunch and there's 2 bunches. 1 piece of watermelon. So plus a watermelon. And then I'm going to take away 2 cherries. So take away 2 cherries and then add 1 watermelon. So here the watermelons are like terms, so we can add W and W and we end up with 2 watermelons. The order here doesn't matter because we're adding the terms together. And then we've got 4 cherries and we're taking away 2 cherries and they're like terms. So I can get rid of 1 set of cherries or 1 group of cherries. So I'm left with 2 cherries, 4 minus 2. Okay, in the last example, I've got 2 bunches of bananas. They're each represented as 3B, where B is an individual banana. I've got 2 strawberries and another 2 strawberries here. But you'll notice that there's 2 in the picture and then we're taking away 2. So they're actually going to cancel out. 2S minus 2S makes 0S. And we actually don't need to write that term down. We're going to talk about the zero principle in a little bit. And it's important to know different ways to make 0. We can add the 3 bananas and the other 3 bananas to get a total of 6 bananas. We can use algebra tiles to represent terms as well. So we need to pick a color to represent positive and a color to represent negative. I usually do positive is red and blue is negative. So hot for red and blue is cold. So we are going to look at the big square is called x squared because it has a length of x and a width of x. X times x is x squared, which means the blue large square is called negative x squared. This is an x tile, and this is a negative x tile. And the little tiny square is just a 1, and negative 1 for the blue. And if we add a red and blue of the same size, so in this case a 1 and a negative 1, that adds to 0. That's what the zero principle is all about. If you add the same numbers of red and blues with the same shape, you can make 0. It asks here, how can you draw 3x? You're going to have 3 of our x tiles, and you'll notice this time I'm drawing them vertically instead of horizontally. It doesn't matter, each one of these is x, is the type of tile, and there's 1, 2, 3 of them. So remember, 3, the coefficient, tells us how many. So I'm going to pause for a moment. You might want to pause the video. And I'm going to let you draw a picture of what 7x squared plus 2x minus 5 minus 5x squared plus 2x plus 1 would look like with algebra tiles. If you wish to do this without, try and highlight the like terms. Pause the video here and try it. Okay, hopefully you've had a chance to pause the video and try to collect the like terms together. If you were trying this without algebra tiles, hopefully you were able to highlight the like terms. So 7x squared and negative 5x squared are like terms. They would collect to give us 2x squared, because you have 7 of something and you're taking away 5 of the same thing. Positive 2x and positive 2x adds to positive 4x. And finally, the constant terms. So the negative 5 plus 1 gives us negative 4. Let's see what that would look like if you decided to draw out a picture. So here we have 7x squared plus 2x minus 5 minus 5x squared plus 2x plus 1. If we look at the large squares first and we put them together, what you'll notice is if you have a bunch of pairs that are going to make 0. All of these big x squareds are going to cancel out because these represent positive 7x squared and this represents negative 5x squared. So you're going to have 5 pairs canceling out and you're left with just 2x squared. Moving on to the thin rectangles, I've got 2 x's here and another 2x. They're both positive, so plus 4x total. And the small constant tiles, the 1 tiles, we've got negative 5 and a positive 1. Got some 0 pairs to cancel there, 1 pair, and we're left with just minus 4 when we're done. Hopefully when we check our answer, we get the same result. So you can either use algebra tiles or you can work on highlighting pairs of like terms and collecting them together.